Okay, so this is part two. Well, we talk about compounded statements. For example, you have two sentences, you use and to combine them, or you have two sentences, you use or to combine them. So, another connective we can use is actually if then. For example, I tell you if you enter Mandy's office, then you need to pet her cat. So you see two simple sentences here. One is you enter Mandy's office, the other one is you need to pet her cat. So I'm combining these two sentences using if then. So this is one kind, another kind of connective that we can use if then. So as you see, P is you enter Amanda's office. We can represent you need to pet her cat by Q. So if you enter Amanda's office, then you need to pet her cat. If P, then Q. And here is the sign that we use. If P then Q. So that's a conditional statement. So P is your antecedent and Q is your consequent. So, for example, if I tell you if you don't enter Amanda's office, then you don't need to pet her cat, and I ask you to change that to symbols. So, you know that P is you enter Amanda's office, right? So, here you go, P. It says if you don't enter Amanda's office. So, what do we have? Negation. So, if not P, then so if then that's the sign for conditional statement. You don't need to pet her cat. You need to pet her cat. You represent that using Q. It says you don't need to pet her cat, so that's the negation, not Q. So we use symbols to change this statement, right? So if not P, then not Q. So well, if you invest in Widget Incorporated, then you get rich. So again, you invest in Widget Incorporated, you can represent that using P. You get rich, you represent that using Q. So it's a conditional if P then Q, right? Guys, there are different ways of, mentioning a conditional statement. For example, we can say Q if P. You get rich if you invest in Widget Incorporated. It's exactly the same as the first one, okay? They're equivalent. So it's just another way of mentioning, a conditional statement. So, or you can say P is sufficient for Q, or you can say Q is sufficient for P. So make sure that you're familiar with different forms of mentioning a conditional statement. Well, it's in your textbook too. I leave this section to you. So provide examples for yourself and mention a conditional statement in different ways. You can use this slide to help you. Okay, so look at here. We have P and Q. P is I will do well on the test tomorrow, and Q represents I will study tonight. So I want you to replace P and Q, and change A, B, and C, statements into symbols, okay, using P and Q. A says, if I will study tonight, then I will do well on the test tomorrow. B, I will study tonight and I will do well on the test tomorrow. And C, I will not study tonight. So I want you to change these statements into symbols. Well, I give you 2 minutes. Okay, go ahead. We have P and Q. So change A, B, and C statements into symbols. Okay, so let's see. Part A. If I will study tonight, then I will do well on the test tomorrow. Okay, well, it's conditional. We have if then. Okay, so if I will study tonight, guys, I will study tonight is Q. So if Q, then I will do well on the test tomorrow. I will do well on the test tomorrow is P. So be careful. The first one is if Q, then P. Look at the second one, B. I will study tonight and I will do well on the test tomorrow. I will study tonight. I will study tonight is Q. And is conjunction. So here is the sign for and. I will do well on the test tomorrow. I do well on the test tomorrow is P. So B is Q and P. C, I will not study tonight. I will study tonight is Q. I will not study tonight is not Q. Negation, right? Okay, so here you go. These are the answers that we have. Okay, so we have another way, right, that we want to discuss here to combine two statements, if and only if, okay? So let's say P represents you invest in Widget Incorporated and Q represents you get rich. Well, I tell you, if you invest in Widget Incorporated, then you get rich. So if P, then Q. Okay, guys, if P then Q is true, it doesn't mean that if Q then P is necessarily true. Okay, so if you invest in Widget Incorporated, then you get rich. That's if P then Q. If you get rich, then you invest in Widget Incorporated is if Q then P. Okay, if Q then P. Well, if P then Q is true, it doesn't mean that if Q then P is necessarily true, okay? However, okay, if you have, a situation that if P then Q is true and if Q then P is also true, okay, we can have a biconditional statement. Okay, in that case, instead of writing if P then Q and if Q then P, we can actually, use biconditional. So we say P if and only if Q. Okay, so here is, here's the statement that we use. Here's the symbol that we use. So P if and only if Q. If and only if. Here we go. So biconditional. Let me give you one example that if P then Q is true and if Q then P is also true. Let's say we have two statements, so we actually represent them using P and Q. P represents a triangle is equilateral, so and Q represents a triangle's angles all measure 60 degrees. So equilateral, it means you have a triangle that all sides are the same. For example, if one side is 2 centimeters, the other side is 2 centimeters, and the third side is also 2 centimeters. So a triangle's angles all measure 60 degrees. Okay, so let's see. If P then Q, if a triangle is equilateral, then its angles all measure 60 degrees. What does it mean? If you have a triangle which is equilateral, okay, for example, you have a triangle, okay, well, one side is 2 meters, the other side is 2 meters, and the other side is 2 meters. If you have that, well, in that case, your triangle's angles all measure 60 degrees. For example, if this angle is 60, this one is also 60 degrees, this one is also 60 degrees, right? So, if all the angles of a triangle measure 60 degrees, then the triangle is equilateral. So, if you have a triangle that all the angles measure 60 degrees, this one is 60 degrees, this angle is 60 degrees, this angle 60 degrees, then all the sides are the same. You have an equilateral triangle. For example, if this side is 5 meters, this side is also 5 meters, this side is also 5 meters. Okay, so if P then Q is true, if Q then P is also true, so you have a biconditional statement, right? P if and only if Q. Okay, so a triangle is equilateral if and only if its angles all measure 60 degrees. So that's the way I can use if and only if, right? In this example. So a triangle is equilateral if and only if its angles all measure 60 degrees. Okay? And guys, doesn't matter you say P if and only if Q or you say Q if and only if P. Okay, so very similar to conditional. So these are different ways of mentioning a biconditional statement. So I leave it to you. So read this table and, well, provide examples for yourself, okay? So symbolic statements with parentheses. Okay, so guys, parentheses in symbolic statements are very, very important actually in logic because they tell you which statements have been grouped together. Okay, what does it mean? Look at here. I have a negation sign, then in parentheses I have P and Q. It means that the negation of the entire statement P and Q. It means you have P and Q and the whole statement has been negated, right? You have a negation and then you have parentheses P and Q. The whole P and Q, the entire statement is negated here, okay? Well, if I remove the parentheses, well, what does it mean? It means just P is negated and I have not P and Q, right? So P is the only statement which is negated in this case. So that is why parentheses are really, really important, okay? They tell you what statements have been grouped together, okay? Well, when you are writing in words, commas are used to indicate the groupings. They tell you what statements have been grouped. When you have a comma, whatever you have before is one group, whatever you have after comma is a separate group, okay? So well, parentheses are very, very important, okay? For example, look at here. We have Q and not P, okay? So we have them in parentheses. We have conditional, and then we have not R, right? So look at that. As you see, Q and not P, they're in parentheses, so it means that they have been grouped together. So how can we actually read this symbolic form? We say that if Q and not P, then not R. So just look at comma. If Q and not P, whatever you have before comma is one group, so Q and not P. As you see, we have parentheses, one group. Then you have comma, then not R. And whatever you have after comma is a separate group. And here we just have one statement, so, okay, not R. Look at the second one, Q and then you have in parentheses, if not P, then not R. Well, here you go. If not P, then not R. So it's in parentheses. So these are the statements that are grouped together, right? So statements to group together. So not P, then not R. So let's see how I write that using words, okay? So I have Q, comma, and if not P, then not R. So just look at comma. Whatever you have before comma is one group, so it's just Q, one statement, all right? And after that, you have a separate group. After that, we have if not P, then not R, right? So that's a group. So that's what commas and parentheses are really important. They tell you which statements have been grouped. So let's say I do not have parentheses. So guys, first of all, you need to look at the parentheses and commas, okay, if you have words, to see which statements have been grouped together, okay? In a case that you do not have parentheses, in that case, what should we do? Okay, you look for the most dominant connective that we have. Whatever we have before the most dominant connective is one group, and whatever you have after the most dominant connective is a separate group. Okay, so what is the most dominant connective? So here are the rankings. Okay, the most dominant connective is biconditional. That's the strongest one. After that, you have conditional. Then we have conjunction, disjunction. So we have actually and or. So they have the same strength. Okay. And then negation is the weakest one. Okay. The least dominant connective that we can have. Okay. So let's see. Well, these statements are given to you in this example. Okay, well, there are no parentheses. So, because there are no parentheses, what we do, we look for the most dominant connective. Look at the first one. Okay, I have conditional, I have and, I have negation. Okay, so the most dominant one is actually conditional, right? So most dominant connective is conditional. Whatever you have before is one group. Okay, whatever you have before is one group. Guys, before we just have one statement. Okay, so it's not group with anything, it's just by itself. And whatever you have after the most dominant connective is another group. Here you go. Okay, so you can say if P, then Q and not R. Q and not R are grouped together, right? So what type of a statement then we have? So conditional, because that's the most dominant connective that we have. Okay, so I'm gonna answer the next one too. So as you see, second one, I have and, I have conditional, I have negation. So what is the most dominant connective? So among and, conditional and negation, so that's a conditional, right? So well, whatever you have before the most dominant is one group. So before I have P and Q, so that's one group. Whatever you have after is another group, so not R. Well, not R is just one statement. Guys, if you want, you can put parentheses. If you don't want, just leave it. It's just one statement, right? Not R. Okay, so here we go. What type of a statement do we have? The most dominant is, conditional. So we have a conditional statement. Okay, so, well, I leave the rest to you to answer. So I give you around 1 minute. Go ahead. Okay, let's look at the third one. We have P, we have if and only, we have Q, we have conditional, if then, and then we have R. So we have both conditional and conditional. Which one is the most dominant connective? Okay, that's both conditional. So whatever you have before is one group. So before we have P, just one statement, and whatever we have after is another group. So after we have if Q, then R. So here we go. So the type of a statement then is biconditional. Biconditional. Here we go. Well, look at number 4. Well, we have conditional, we have biconditional. Again, which one is the most dominant connective biconditional. Whatever you have before is one group. So before we have if P, then Q is one group. And whatever you have after is another group. After we have R is just one statement, right? So again, we have biconditional statement. Okay. Look at number 5, guys. We have and, we have negation, we have conditional, we have or. Which one is the most dominant connective? Well, is the conditional. Whatever you have before is one group. Before we have P and not Q. And whatever you have after is another group. After we have R or S. Here we go. So we have a conditional statement. Guys, as you see, we have P, Q, R, S. So you have an example that you have 4 statements, right? For example, P is I go to university. Q, I take, Janet courses. R is, I listen to online lectures. And S is, let's say, I complete the assignments, okay? So we have 4 statements, P, Q, R, S, okay? So look at the last one. We have 2 connectives and, right? Or, here we go. Guys, we know that, they have the same level. So which one is the most dominant? We don't know. They have the same level. Well, we cannot group that. Well, they have the same level. We cannot group any statements, right? Because they have the same level. So last one, it actually shows the importance of, using commas or using parentheses, okay? You have 2 connectives, they have the same, level, so we cannot group any statements. Here we go. So, truth tables. Truth tables are really, important in logic, and actually they can show visually the value of a statement, for example, if it's true, if it's false, okay? And truth tables actually can help us find out whether or not an argument is actually valid, okay? So you remember the important statements that I say I'm going to go back to the one was the statement P and Q is true. If both P and Q are true, well, and we had similar statement for or P or Q is true if at least one of the statements P and Q is true. Well, I told you we are gonna get back to these statements. Well, when you read them, maybe it's not very clear, but if I use a table, you see, visually what these statements mean, okay? Well, I'm going to go back to this example. If you invest in Widget Incorporated, then you get rich. You didn't invest in Widget Incorporated, therefore you didn't get rich. You have an argument and you want to see whether or not this argument is valid. Okay? So, guys, whenever you are given an argument and they ask you whether or not the argument is valid, there are 4 steps that I want you to follow. Step 1. Break the premises into several statements. Okay, break the whole argument into simple statements and call these statements P, Q, R, like that. Okay, so here I see 2 simple statements. One is that you invest in Widget Incorporated, and the other one is you get rich. So you invest in Widget Incorporated, I call that P, and Q represents you get rich. Okay, so that's step 1. Step 2, well, express the whole argument using symbols. Sure. Okay, guys, read the first line. If you invest in Widget Incorporated, then you get rich. Okay, you have a conditional statement, if then. Okay, change that into symbols. If you invest in Widget Corp Incorporated, if P, then you get rich. Q. Here we go. That's first line, guys, here. Look at line 2. Okay, you did not invest in Widget Incorporated. You invest in Widget Incorporated is P. You didn't invest in Widget Incorporated is not P. So that's line 2. Okay, therefore, guys, when we have therefore, it means now you have your conclusion. Here is the sign for conclusion. Okay, conclusion. Whenever you see therefore, it means we have the conclusion. Therefore, you didn't get rich. You get rich is Q. You didn't get rich is not Q, the negation. So that's step 2. I change everything, the whole argument, into symbols. Okay, so guys, this line that we have here, it separates the premises from conclusion. So we have line 1, we have line 2, and then we have the conclusion. We separate them using a line. Whatever you have above the line, these are your premises. So here we have 2 premises. One is if P then Q, and the second one is not P. And whatever you have below the line, that is your conclusion. Don't forget to label them. That's really, really important, okay? Helps you, well, when you are building your truth table. So, if P then Q, first line, is a conditional statement. Second line, okay, is negation. Your conclusion is also negation, not Q, right? This sign that we have means therefore. It means we have the conclusion. Okay, now step 3, okay, you make a truth table, and a step 4, you make sense of your truth table. So how can we actually draw a truth table? So let's find out. Okay, guys, let's say for example I only have one statement P. Okay, so if you have only one statement P, guys, we said that when you have a statement in logic, it can be either true or false, but not both, right? So if you have a statement P, it's either true or false. That's it. Okay, if you want to see, you want to show the negation, not P. Okay, negation of a statement has the opposite value. Okay, if your statement is true, the negation is false. If your statement is false, then the negation is true. Okay, so here we go. Now we have a truth table, as you see here, P and not P. We have a truth table for a statement and its negation. So a statement and its negation, they always have opposite logical values. If your statement is true, negation is false. If your statement is false, the negation is true. Okay, so let's talk about truth tables. Okay, well, let's stop here. I give you a break and then I come back with the rest.